Lalbar really dares to think and act. I thought just using an old oil barrel as a cart was enough. Unexpectedly, Lalbai even used it to make motors. One must say, small workshops have their own tricks. The materials for motor making are exactly as you see here. They are mainly from barrel lids or bottoms. Because of their small size, large parts cannot be made. Before processing, a worker first cuts off the raised edges with a rotary cutter. For plates with openings, those parts are punched out. This way, a relatively flat sheet is obtained. And the scraps can still be sold to steel mills. Not a bit is wasted. Next, the sheets are flattened as much as possible with a rolling machine. As everyone knows, iron sheets for motors, nails, or rotors are usually made of silicon steel. Its high magnetic permeability and low iron loss give excellent electromagnetic properties. But oil barrels are mostly low-carbon steel. Their only feature is higher strength and toughness. While Altöl uses them for motors here, besides cost, is probably still just cost. Since oil barrels are coated with various paints, after punching them into round plates, workers soak them in a tank to remove the paint. The coating is stripped off as much as possible. In the indoor workshop, workers punch holes in the round sheets with machines and standard molds. Rotors are classified by structure, working principles, and materials into various types. Experts can tell from the punch shapes Lalba made which type of rotor these laminations are for. The dragon type rotor is named because its shape resembles a dragon, hence the name. Now the worker groups these punch plates one by one. A rotor needs a large number of laminations. To save effort, Lalba groups them by weight. There will be errors, but not too big. After grouping, each set of laminations is firmly fixed together. Lalba does this by casting aluminum. The worker places the group into a casting mold, then compresses it with a hydraulic press. An insert lifts the mold with the hydraulic ram. The worker pours molten aluminum into the groove. Then pressure is applied again. The molten aluminum is forced into the mold and rotor core slots. Keeping the pressure for a while completes the rotor core. After machining and trimming the iron core surface, the prepared rotor shaft is installed. Finally, it is assembled with the casing and accessories. After painting, it looks quite decent. But no one knows how well it really works.